a couple of things before I get going. I think I'm getting over the same cold that Travis has, so if I cough into the microphone like I just did, I apologise in advance. Secondly, I'd like to acknowledge that the Eyre and the Adlamatha peoples, and acknowledge the Pertalapa people, hope I pronounced that correctly, on whose traditional country we undertook this survey work. Also, the station owners, the Brooks family, the Sheeans, the Ogilvies and the Hallett family, thank you for allowing us access. Strike Energy for allowing them access to their wells as well. Also, a thank you to Glenn and Nikki Harrington and Andy Love at Flinders University for their review help on this work. And last but not least, our major sponsor, the Australian Government. Speaking of which, I will start with a word from our major sponsor. In 2012, the Australian Government established the Independent Expert Scientific Committee into Coal Seam Gas and Large Coal Mining, or IESC, to provide independent expert scientific advice concerning the impacts such developments may have on water and ecology resources in areas impacted. As part of this initiative, DUNO was provided funding to collate and ground truth groundwater, surface water and ecology information in areas potentially impacted by CSG and coal mining, and to develop and conduct vulnerability assessments. So this presentation focuses on a very small component of that work. In fact, this was something of a last-minute request, which was then going to contribute to an appendix to an ecology report. But sometimes things don't work out the way they're meant to, and this took on a life of its own. We believe we've made some important discoveries which have in some cases changed our understanding of the hydrogeology and hydrostratigraphy of this particular region. It has also led us to think about, briefly, the definition of what a GAB spring is with respect to their legislative protections. So the spring complexes included in this study were identified as those most at risk to either reductions in flow or changes in water quality that might occur as a consequence of any potential CSG developments in the Wiener Trough area of the Cooper Basin. And wrong button, that one, the Wiener Trough up there. Of particular interest was the Lake Blanche region, Lake Blanche Spring Complex, because this was the spring complex located closest to this potential CSG activity. Other spring groups we looked at included Reedy Springs, Peter Morra spring group here along the edge of the northern Flinders Ranges, 12 Springs, and Lake Callabonna, which is a shame that Travis isn't here because I'm sure he had some great stuff to say about this particular site. It's not very well visited, and we saw and learnt a lot of new things. An important part of this assessment was determining where the springs get their water from. So this study focused on obtaining groundwater samples from 5 of the major aquifers in the region. Using this cross-section for some context, these aquifers included the Fractured Rock Basement Aquifer, the Patchawarra Formation in the Cooper Basin, which also happens to be the main target for CSG exploration, the main GAB aquifer, which constitutes the Katniawi Formation, the Arjabukna Sandstone, and is here referred to as the JK aquifer. What we think is the Kurikana Sandstone aquifer, and I'll get to that in a minute, and the Cenozoic aquifers at the very top. So just some conclusions to begin. We'll try and briefly, in the time allowed, detail the evidence for these conclusions. Firstly, we're not only able to use hydrochemistry to distinguish between major aquifer types encountered in the study area, but we're able to make some reasonable attempts at identifying which groundwater sources were supplying the various spring groups. Of note is that the Lake Blanche spring group appears to be supplied from the shallow aquifers as opposed to the deeper JK or JK aquifers or anything deeper than that. Secondly, we identified potentially the Kurikiana Sandstone, which is a much thinner and younger unit, but within the same general package of rocks as the GAB, as another Artesian aquifer within the region. And this is something that hasn't really been recognised before. Finally, given that we identified that springs in the region may have a variety of groundwater sources, some exclusive of the GAB, it led us to wonder briefly about the management and legislative implications of this. So, just briefly, I'll just throw this slide up to give those interested an idea of the methodology. This slide presents an indication of our sampling sites and also historical data sites that we included. It also gives us an idea of the analytes we analysed for, including major ions, the environmental isotopes hydrogen-2 and oxygen-18, isotopic strontium, as well as the radioisotopes chlorine-36 and carbon-14. Now, I'm aware there are some non-hydrochemists in the audience. You're accepted, Paul. And you may not understand any of the technical detail, and I'll try and gloss over as much of that as possible. What I want to try and get across in the next few slides is how this hydrochemistry data could be used to clearly discriminate between groundwaters from different aquifers. So first of all, we'll look at a Piper diagram which presents the proportional concentrations of the major ions we analysed for. And as you can see, just colour coding the results gives you a fairly good discrimination between the various aquifer types in the groundwater results. However, the main point, this is not the presentation I was hoping, but anyway, we'll do it with this pointer. The main point, the main difference we want to show here, though, is the difference between the JK aquifer and Patchawarra formation aquifer groundwater results and everything else. These ones here appear to be dominated by processes that release sodium bicarbonate into solution, whereas these ones here are more dominated by processes that or mineral interaction processes which are governed more so by things like gypsum and halite. With respect to the springs, we found spring groups with chemistries comparable to all the groundwater types, although those from the northern and eastern parts of the study area, so Lake Blanche and Lake Callabonna, were more likely to have, or were likely to have chemistries that fitted with this latter group. Stable isotopes, hydrogen-2 and oxygen-18 and isotopic strontium are useful analytes to study when looking at environmental influences on water because they are sensitive to fractionation. They can therefore be interesting analytes to examine for fingerprinting purposes because they may allude to different environmental histories. The main takeaways from the stable isotope data were how depleted the JK and Patchawarra formation groundwater results were compared to the others, and as you can see, like the major ions, they all, just colour coding, they all seem to plot on a different part of that graph. And also similar to the major ions is that we also saw a difference in the spring results. So results from the water from Lake Blanche and Lake Callabonna seem to plot in the enriched part of the graph, whereas those were more likely to supply from the JK aquifer plotted in the depleted part. Of note in the strontium results is that groundwater from the fractured rock and the Patchawarra formation appeared more enriched compared to the Cenozoic and the JK aquifer groundwater results. Another thing to note, you'll see this trend in the JK aquifer and the Patchawarra formation results when you compare the isotopic strontium to just total strontium. And this is indicative of some kind of evolutionary trend observed in the data. With respect to the spring results, we had a very enriched result from the Peter Morris spring group. And this suggests that at least some of these springs may be supplied from the fractured rock basement aquifer. And this is probably not surprising given their location abutting the northern Flinders Ranges. Moving on to the radioisotopes, and these are traditionally used to age groundwater based on their radioactive decay and understanding how these radioisotopes enter the aquifer system. So in other words, how the atomic clock is set. During this study, we used this data to provide a relative indication of the age in order to aid our fingerprinting exercise. Now, of note is that the groundwater from the JK, Patchawarra and Kurikiana sandstone aquifers is quite old, relatively old, compared to that from the fractured rock and the Cenozoic aquifers. The other thing to note with respect to the spring results is that many of them appear appear relatively young when compared to the JK aquifer groundwater results, and again, a lot of these come from the Lake Blanche and Lake Callabonna regions. So that covers the first conclusion. Moving on to the second conclusion with respect to identifying the Kurikiana sandstone as a potential Artesian aquifer in the region. And this was something of a surprise to us, because when we started this study, we didn't even consider this an option. It hadn't been mapped in the region. So this interpretation didn't come about through a lot of brand new fieldwork or expensive techniques. It was basically came from questioning old interpretations and then checking historical data found in EnviroData SA and SARIG. So in other words, it was just a good old-fashioned paper chase. And it began with an email, as it says there. Well, in fact, it began with as I was reviewing the hydrochemistry and making cross-sections to help describe the hydrogeology of the region, I started finding discrepancies in the interpretation of where the top of the JK aquifer was. And I couldn't make head or sense of this. So I asked Brent Jensen-Schmidt at DSD about this, who's done a lot of work on this, his opinion. And he came back with a very interesting email. He said that in the seismic data for that region, there's actually two reflectors. There is a deeper reflector, they're in green, and then a shallower onlapping one. And historically, both had one time or another been interpreted as the top of the JK aquifer. So, hence, we have a problem, Houston. So we decided, given the time and the budget, that it would be a good idea if I went through some historical logs to see if I could identify a sand unit at a shallower depth that might help explain the shallower reflector horizon. And that's what I did next. And to my surprise, time and time again, we found a sand unit or a sandier unit at a shallower depth. In fact, we found such a unit over 30 times in the area. The depth and thickness encountered for this sand unit were both comparable to the depths and thicknesses reported for the Kurikiana sandstone unit, where it occurs in the Cooper Basin region to the north. So this led us to speculate that this unit was in fact the Kurikiana sandstone. And because it is very thin, it's a bit hard to find, but that whole central part in this cross-section is a new, I suppose, speculated interpretation for this area. So what does this mean? Implications. So these wells that we think are actually completed in the Kurikiana sandstone have historically been interpreted as completed in the deeper JK aquifer. So it was on the basis of these interpretations that the following corrected potentiometric surface for the JK aquifer was published in 2012. And as you can see, there is a large radial depression was interpreted using this data in the vicinity of Lake Blanche and Lake Callabonna. However, from this study, we felt that at least two of these wells were either completed in the Kurikiana sandstone or due to well construction failure were actually receiving a lot of their water from the Kurikiana sandstone. And so if you replot that data without those two wells, you get something like this. So there's still a depression. It is much smaller and much shallower and is now focused on one well only. And if I were to review that, that would be the first place I'd go to check. So just getting back to the conclusions, I'd like to finish with a focus on this last point concerning the management and legislative implications of all this. So at first blush, there's some positive news for CSG exploration components in that the springs located closest to their operations do not appear to be supplied from groundwater from any aquifers that are immediately associated with their activities. However, there are 2 points to consider here. The first is that the assessment is based on current hydrogeological conditions. Testing scenarios in which these conditions change due to development is a strong recommendation. Secondly, assessing risk needs to be more holistic, and this was a point that was always pushed to us by the BA and the IESC process. And so issues such as well construction and decommissioning may have to be considered in a lot more with respect to their impact on the shallow aquifers. Secondly, when we think about groundwater resources in this part of the world, we predominantly think about the GAB first and foremost, and then we might think about things like the Cenozoic aquifers later. This work demonstrates that not only does the Cenozoic aquifers need to be lifted in prominence, given their apparent importance in supplying spring-related ecosystems, but the Kurikiana sandstone, or whatever it turns out to be, needs to be discussed as a quantifiable groundwater resource. Thirdly, and finally, the wording of legislation used to protect these spring environments may need review. Wording may be based on old assumptions concerning the JK aquifer being, if not the predominant, maybe the only supplier of water to springs, and may therefore inadvertently exclude springs where this has since turned out not to be the case. We do not believe that this is an issue with the way the South Australian Arid Lands WAP is written, but it might well be a case, an issue with the way the EBBC Act is written. And with that, I'll conclude. Thank you.
Thanks, Mark. That's two questions to Mark immediately. I was wondering about, you don't think about the effects of the Carmichael coal mine might have on the GAB up in central Queensland, given that it's given the most ecologically important springs in the whole GAB, Edgbaston, Belcoldar, the root sort of stuff.
I probably know as much as you, unfortunately. Any opinion I'd give would be a personal opinion and probably best left outside.
This process, the IESC process is time to inform